Hi guys, Mr. T here, and come to give you a little bit of help on 1.4. So this is the 1.4 online homework help video. Okay, so you may want to jump around to the parts you need the more help with. Okay, so we're going to jump over here into yeah. So our assignment was 1 through 10, 10 through 16. So first one here, inverse is again just switch x and y. So that's this first guy, just switch those x and y's there. And again, some more of the same. And just switch those x and y's, you're good there. And rewrite the ordered pairs. We've done some of those. I think we're good. Let me try one of these because fractions y'all freak out for whatever reason. So let me give that a shot real quick. And so you're going to write y equals x over 7. And we always talk about, what you're going to do is you're going to switch the x and y and then solve for y. So we're going to switch those two guys. So we're going to put the x here, y there, and everything else is going to stay in place. Okay, oops. So how am I going to get y by itself? Well, I'm just going to multiply both sides times 7. And then we end up with 7x equals y, which more properly written would be 7x equals f of -1. So of x, because that's how you write inverse. And now we know that this goes with that guy over there. That's why they have that notation. And you would plug that in. All right. So don't try to get into those crazy shortcuts. Well, you just move this over here. No. Why are you making it hard? Just switch the x and y. And then whatever you have, solve for y. Don't make it hard. Keep it simple. All right, now here we go. Another one of those. Not too bad. Should be able to handle that one. Let's try this one. It's been a little bit more challenging for some folks with how to manage with this guy. So let's first of all, we got to get our inverse. Okay. I don't know why this thing keeps on, every time I do that, it goes real big on me. But we can live with that. So our inverse ends up being, so we got y equals -7x plus 7. We're going to switch the x and the y. They're going to switch positions. So get our x here, our y there. Everything else comes into place. Subtract 7 on both sides. You'll give me the grace to be able to skip a couple of things. And then we're going to divide all the way through by -7. Okay. And so I'm going to separate this out actually. So, because I think we're going to need them separate for graphing purposes, make it easier. So let's do it separate like that. So that's going to leave you with -1/7 x plus 1 equals y. Okay, so there you go. Now, the next piece here, so this is what would go into that first blank, right? That'd be all good. Now, what's all this other stuff? Well, what happens here is you see there's an f of x inside this parentheses inside the inverse. So what they're saying here is if you take this piece here and plug it in for that x right there, what will it be equal to, greater than, or nothing as if we did it the other way around? Okay, so and the answer is if they're inverses, they're always going to be equal. It should always come out to be x. And so I'm going to pause here and do some work and then show you. Okay, so I got this new page here and we got the original function and the inverse function. So what they're talking about here is we're going to take the inverse function and put inside the original function. So I'm going to rewrite the original function. Now I'm going to do -7, open parentheses, close parentheses, plus 7. So this is where x used to go, right? So now we're going to take all of this and put it right inside here. Okay, so this is where x was, and so we're going to remove it and put this other thing in. And now people get said, "No, hold on a second, you took x out, and now you're putting this other weird x back in?" No, 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 no. See, it's just a placeholder. It's just a placeholder, and that can be very odd and weird at first, okay? And so if you get caught up in trying to track down all your x's, that's going to be a problem. You're going to be chasing your tail, okay? What you need to do is that this unknown thing, okay, was substituted with this thing, okay? So we took that out and put that in because whatever's inside this parentheses is what goes in for the x. And so now we just got to simplify, okay? And what happens here is when you multiply through by -7, those cancel out. That ends up being 1x minus 7 plus 7, which just gives you x. Okay, so all right. So when we plug the inverse in for that function, it gives us x. Now we're going to reverse this dude. Okay, now I've got the correct color. And so I'm going to take the original f of x and plug it into this spot here. This is called a composition of functions because we're making a function composed out of other functions, composition of functions. And so again, when I multiply through by -1/7, so negative times negative is positive, the 7's cancel, and that's going to end up giving me just a 1x, okay? 1x. And then -1/7 times 7 is going to give me a -1. Bring down my +1. These two reduce to 0. And again, I get x. So when we come back to this other page here, you're going to see that these guys are going to be equal to x. Both of them are. Okay. All right. So let's jump on in here to the next piece here, giving you some little help with the graphing piece of it. Now, the original function, okay, is this guy here. And it was, what was its y-intercept? 7, right? Wasn't it 7? Yeah, it's 7. And so I'm going to come up here to 7 and click. And then I'm going to come down 7, right, 1. Is that a -7 slope? It is. And then when I let go, it fills in the entire line. So you just started with your y-intercept, count off your slope, and come down. If it ends up telling you that it's wrong, another thing you could do is hit Control plus and get this thing a little bit bigger here, guys, so that you can work on it a little bit better. Okay, so you can see what you're doing. Okay, so for our next piece, we're going to do the inverse, and its y-intercept was 1, and it had a -1/7 slope, right? So you see, all I did was start there, and when I let go, it fills the whole thing in. If you fold it across that dotted line, it's symmetric, and that's how we can check to see if two graphs are inverses of each other just by looking at their picture, the graph. Okay, so I want to get this back down by hitting Control minus, slide back up here. And guys, don't work on those little things. Make them bigger. Make it, a little easier to be more accurate, and then you have to redo it so many times. Get so upset about it. So that's more the same thing. Okay, I just looked at the example of this. It was pretty straightforward here, guys. So what they're trying to tell you here is this: is you got this paint can that can cover so many square feet for how many whatever, and so they got this formula. And they're saying, hey, what is going to be the domain? And well, it's going to be 200 to 400. So that's what goes into here, 200 to 400. Okay. But what is the range going to end up being for this? What happens when we plug in 200 here? Okay, we're going to get 2,000, and when we plug in 400 here, it's going to give you 4,000. So that's going to be your two endpoints of your situation. Okay, so your endpoints for this original function are going to be 200 comma 2,000, right? That is your original, and then you're going to have 400 and 4,000 because it's just multiplied times 10, right? So this is what goes with your original function. So what's the inverse going to be? The inverse, it's just simply 2,000 comma 200 and 4,000 400. Okay, so put your 200 400 in here, I believe, and then you're going to do switch x and y, solve for y. I think that ends up being a equals c over 10, I think. And then you're going to come down here and graph, but you're going to graph these ordered pairs in red, not the green ones, because it asks you to graph the inverse. So I think that should be enough for that without having to do the whole thing for you. All right, and then 13. This is an interesting thing. It says the graph of the function is given. Tell whether the function's inverse is a function. Complete the explanation of your reasoning. All right. If the inverse is not a function, tell how you can restrict the domain of the function so that its inverse is a function. And that just gets a circular double talk, right? So let's just start off here. All right, with the first thing first. All right, so this is the absolute value with a negative in front of it. That's all it is. And so when we take and find the inverse, I showed you a little shortcut. If we were to take and flip this on over, okay, the inverse of this guy is going to end up being, well, okay, get just, so if you flip this across the y equals x line, what are you going to get? You're going to get this and this guy here, right? So if you take the blue function and you flip it across that y equals x line, you're going to get this other guy. So does the red one pass the vertical line test? And the vertical line test says I can just put a vertical line through any point and it's only going to cross in one place, right? Does it pass that test? No. Okay, so that's what they're talking about. They're saying, okay, what would the inverse be? All right, and would it be a function? And we find out the answer is no. Well, what could we do to the original function that would make it be okay? Well, what if, let's see if I can get my magical box here to show up. Yeah, maybe this will work. What if this part of the function never existed? Well, that means the inverse would not have had this part, and it would have been just fine, right? And that's what they're talking about. Is there something I can do to the original so that when I do the inverse, it still fits the definition of a function and passes the vertical line test? That is what they're talking about. So they're saying, and what that's going to be is I could have x is less than 0, but you could do just the opposite too. Okay. What if I did the opposite and got rid of these guys? Wouldn't that work as well? Okay, and so we could do only x is bigger than 0. All right, and I think that should get you well on your way for that. But that's setting you, what that does is set you up for this next page. Okay. Well, let's back up just a little bit here. Okay. Is there something I could do to check this guy here, this one here in red, without having to draw it, okay, well, what we're going to say here is this. If I draw a vertical line through this spot right here, is that that's the -6. Let me do it in green. Drawing a vertical line through -6, isn't that going to be the same as if I drew it through here? Wouldn't that be the same thing? Because when I switch it over, it turns into that. So what we're going to say here is this. A vertical line tests the graph that you have. A horizontal line will test the graph that you have to see if its inverse, predicting the future, is going to be a function. And so it's called the horizontal line test. And so, and again, what that means is this. If your horizontal line crosses in two places, that means when you draw the inverse, it's not going to fit the definition of a function because it will fail the vertical line test at that point. And so we could have seen that without ever drawing it at all. We could have used the horizontal line test to check that out. And that's going to be important to us as we go to do, I think, number 15. Do a quick job here with 14. So they're talking about the inverse. Let me quickly draw the inverses. What's the inverse? Switch X and Y, right? And so if I switch 0, 0, that's still 0, 0. Well, what about this guy? That's over 3 up 1. So what's its inverse? So this point right here, let's make it in blue. That point right there is 3, 1. Okay. This is 0, 0. And this point is -3, negative, whoops. Oh, that's going by twos. Apologies. It's going by twos. Didn't realize that. So that is 6, right? It's 6, 2, because it's going 2, 4, 6. And this is -6, -2. Okay. Sorry about that. And then that ends up being, oh, what point is that one? That's a -1, -1, and this point ends up being 1, 1. Okay, so my original function is all in blue. So my inverse, I want to do all those in red. So my inverse is going to be 2, 6 goes over 2 up 6. That's going to be that guy up there, isn't it? Okay, so that is 2, 6. Okay, about 1, 1. What happens when I reverse 1, 1? Well, that's just the same thing, isn't it? 0, 0, still got 0, 0, don't I? What about -1, -1? Well, that's still just -1, -1. But this guy here is going to switch, isn't it? It's going to be -2, -6, which is going to be right about there. Okay? So that would be this guy, right? Let's go through 1, 1, 0, -1, slide on down here to this point. So that is the inverse for that guy. And you should be able to answer the questions from there. Okay? All right, 15. This is the fun one. Okay, we're going to get to use the horizontal line test. And what they're saying here is this. Does this function currently fix the definition of function? But if we turn that around, it's not going to fit the definition of function. Even though it's not connected, the original is good. But when we turn it, it's not going to work because there's several places here that it would fail a horizontal line test. So they said, what if we did just part of it? So which scenario would work for us? So they're going to start off by saying, what if we just started with 5 to positive infinity? So give you an idea what they're talking about here. Okay. They're saying, what if we just cut off all of that over there? All of this right here gets cut off. Okay. So when we do that, we're only left with this portion of the graph. So would this pass the vertical line test? Yes. So that is a function. Okay. Would it pass the horizontal line test? Yes. It also, well, not supposed to be blue. it also passes the horizontal test. It was, again, the horizontal line test for the inverse being a function without saving you the trouble from having to actually do the graphing. Okay, so it kind of is a prediction of a future event kind of thing, as opposed to what you're currently talking about. So if we do from 0 to positive, from 5 to positive infinity, that's okay. So both the inverse and the function and its inverse will be a function. So that's yay. That one works out for us. And so the next thing says, what if we go from 1 to positive infinity? Okay, so what is that going to look like? So 1, so what we're going to do here, we're going to take 1 and cut off here. And so all of this over here goes away. It's gone, right? That stuff over there is gone. Gone, gone. Okay. So this is what we have left. Does this fit past the vertical line test? Yes, because that's a closed dot and an open dot. What we have left fits the definition of a function. However, does what we have left fit does the inverse? So if we come up with the inverse, will it also be a function? Remember, the horizontal line test is for is for that. And so let me see. So if I pass a horizontal line right through here, it passes the horizontal line test. That's good. If I pass it through here, it passes. But if I pass it through right here, it's going to hit 2 spots. So that means that the inverse of this function, yeah, it's still the inverse, but that doesn't fit the definition of function. So B would not be a good choice. Okay, B would be a bad choice. All right, I'm going to do let me do C real quick. So if from 5 to positive infinity works, surely 8 to positive infinity is also going to work, right? Well, what about negative infinity up to 5? Would that work? Now, I'll make this my last one that I'm going to do with you here. So it says if you go from negative infinity up to positive 5, would that work out for you? That means we're going to take this piece off here. And hold on a second. Let me double check what I was saying here. Nope, that's the last one. So what it does say was we're going to cut all this off, right? We're going to cut all of that off. This is going to be gone, right? Gone. Only going to keep this stuff on the left. But real quickly here, let me double check what it said. It said from negative infinity up to 5. Does it include 5? No. So we're just going to do this open dot over to here and say, okay, now we're in good shape. So does this blue part that is left, does it fit past the vertical line test? Yes. Does it pass the horizontal line test? Yes, it does too. So that would be a good choice. Okay. So that's a few of those to get you going here. We got to come down a little bit. So there are 5 more to do. Okay. And I've gone through the first 4 with you. Okay. So what else we got going up here? So we said and through and 16 and 16. I'm going to leave that one up to you. Okay. So maybe I got you pointed in the right direction to a few of those. I know number 15 can be still a little bit confusing. Give it your best shot. Turn it in. Be done with it. Okay. It's all good. So you have a good one. Talk to you later.